So now it's time for us to finally graph the solutions of a quadratic function. Make sure that you have a good understanding about Unit 7 Target 1A, the characteristics of quadratic functions, before moving on to this video. So to have a better understanding of the parabola, let's dig in and actually create our own graph. We have our function here, f of x equals x squared minus 2x plus 3. We have a table and we have a graph. When given the x values, how can we find our y values? Hopefully you said substitution, and if you did say substitution, you are correct. Remember, when we substitute, we're going to replace every x value, or every time we see an x, with the x value listed in the table. When you do that, make sure you substitute in parentheses and then type this exactly into your calculator as it appears. As you can see, that value is 6, and we went ahead and filled that in to our table. Now we're going to repeat this 4 more times. F of 0 is 3, f of 1 is 2, f of 2 is 3, and f of 3 is 6. Now it's really important that you take a moment and make sure that your calculator actually does this, that you know how to get your calculator to do this. And if you don't, please reach out to Mrs. Newman or I, because it's really important that you understand how to get your calculator to do what you need it to do in order to be successful doing this. Once you've created your table of values, you can go ahead and plot your 5 points and create the parabola. Notice it is a rounded off shape. It is not pointed, it's a U shape. And then it has 2 arrows up at the top because it goes on forever, in this case towards positive infinity. Now that you've created your first parabola, what do you notice about the values for f of x? Right here. Hopefully you noticed that they're mirrored or repeat around the vertex. That vertex is at 1, 2. That's that center point. You can see those values repeat, 3 and 3, and 6 and 6. And 1, 2 is right here on your graph, the vertex. The reason this happens is because of the axis of symmetry. I know we defined this in our previous notes, but can't hurt to do it again. It's a vertical line, x equals a number, through the vertex over which the points of a parabola are reflected. In this case, that axis of symmetry is x equals 1 and can be seen here by the blue dotted line on the graph. We typically don't graph them, but I'm showing you this for effect. So if we're going to be graphing quadratic function, finding that vertex is the priority. But what if the vertex is not easy to find? Let's look at this next example here, x squared minus 5x plus 3. How do we find this vertex? Most students typically will tell me, well, let's make the same table of values that we used on the previous example. Okay, let's see what happens there. Those x values were -1, 0, 1, 2, and 3. When I plug in -1, I get 9. When I plug in 0, I get 3. When I plug in 1, I get -1. When I plug in 2, I get -3. And when I plug in 3, I get -3. I don't really see a mirrored value. The vertex is probably happening in here somewhere, but we got lucky. Do we want to always be guessing and checking? Or should we maybe have something that will work no matter the graph? Hopefully you're looking for a formula, and that's exactly what I'm going to give you. When you have a function in a quadratic function in general form, we're going to use those a and b values in order to be able to find the vertex. We use this formula right here. Now this formula can look very scary, so I like to break it down into these 2 bullet points. What this formula means is that we can find the x value of the vertex by dividing the opposite of b over 2 times a, or more simply, -b over 2a. Then once we have the x value, we can find the y value simply by substituting what we found for x and simplifying. So now that we have this formula, let's revisit this problem. So I'm going to go ahead and copy down that formula here so that we don't have to flip the page. I believe that these are on 2 different pages of your note sheet. Now that we have this formula, the first thing I recommend doing is listing out your A, B, and C values. You don't have to do this every time, but at the beginning, I strongly encourage you to do this because it really makes this process a lot easier. In this particular problem, A is 1, B is -5, and C is 3. Next, I create this sort of skeleton Remember, when we substitute in algebra, we always do so in parentheses. So I have negative parentheses over 2 parentheses. The numerator is going to get the b value, in this case, negative 5. The denominator parentheses is going to get the a value, or 1. 2 negatives in the numerator are going to make a positive 5, and 2 times 1 is 2. 5 over 2, either you know that in your head or you're typing in your calculator, is 2.5. Once we have x, we're going to go ahead and substitute that value into y. Again, we plug it in to find y. Again, when we substitute, make sure it goes in parentheses. That is so important. Missing parentheses could make a difference between getting the problem right and getting the problem wrong. So now that we've substituted, you're going to go ahead and type this into your calculator exactly the way it appears. And when you hit enter, you should get negative 3.25. This makes the vertex of this particular function 2.5, comma negative 3.25, and the axis of symmetry, or AOS, x equals 2.5. So let's continue practicing. Now that you see how important it is to have this formula, it's really important that we understand, because the vertex is so important. So we have 3 more problems here to practice. Remember, the first thing we want to do is list out our a, b, and c values. In this case, a equals 3, b equals negative 6, and c equals negative 5. Next, we want to set up our skeleton, negative parentheses over 2 times parentheses. The numerator is going to get the b value of negative 6. The denominator is going to get the a value of 3. 2 negatives in the numerator make a positive 6. 2 times 3 makes 6 in the denominator, and 6 over 6 equals 1. Now, once we have x, we plug it in to find y. Typing this exactly into our calculator, you should get that y is negative 8, which makes our vertex for this particular problem 1, negative 8. Now, these directions do not ask for the axis of symmetry, but if you wanted to, you could still practice anyways. Let's do another one together. So problem number 2, start out by listing a, b, and c. In this case, a is 1, b is 8, and c is negative 11. Next, we need to find our x value. Remember, always substitute in parentheses, okay? Negative parentheses 8 over 2 parentheses 1. We get a numerator of negative 8 over a denominator of 4, which gives us an x value of negative 4. In order to find y, we're going to substitute in. When we substitute in parentheses and use our calculator, we get y equals negative 27. That gives us a vertex of x comma y, or negative 4 comma negative 27. Now it's your turn. Pause the video, try question 3, then come back and see how you did. So go ahead and pause the video now. Okay, let's see how you did. A lot of times students freak out and they think, oh my gosh, I did something wrong because I got a, quote, ugly decimal. As long as you're using the formula and using your parentheses, you should be able to get it right. Don't be scared by an ugly decimal. Now, if every problem is coming out with decimals, something may not be right. But every once in a while, decimals are okay, so don't be afraid of them. Once we know the vertex, it is the most important part, we can then make a table, graph a parabola, and get our characteristics. So make sure before moving on that you really truly understand how to get the vertex. Please reach out if you don't. So hopefully you're ready to go, and we can go ahead and look at our very first problem. We're lucky here. Our first problem has x values filled in, so we don't need to find the vertex. We can go straight to substituting. And when you substitute, you get the following y values. 3, 0, negative 1, 0, and 3. In case you forgot, in order to be able to find these y values, I'm going to show you here just on the first one. You're going to replace the x value in the original problem in parentheses. Type this into your calculator to get 3, and you're going to repeat this 4 more times. Once you get all 5 points, you can go ahead and graph them, plot them, and then connect them to make your parabola. Make sure that parabola is rounded with arrows on the ends. Now that you have your first parabola, congratulations. You should be really proud of yourself. Now we can do all the characteristics. So characteristic time, hopefully you're pros at this by now. The domain, negative infinity to positive infinity. All parabolas have the same domain. Range we read from bottom to top. In this case, negative 1 to infinity. And make sure you have that bracket on the range. The y-intercept is 0, something. I don't see a y-intercept here, so I need to go ahead and substitute. Now I have that work down here in purple, in case you forgot how to do that. In this case, the y-intercept is 0,8. Again, you can't see it, but doesn't mean it doesn't exist. The x-intercepts, this graph crosses the graph twice at 2, 0, and 4, 0. The zeros are those x values, x equals 2 and 4. The vertex is right here. The beautiful thing about having a graph first is that you don't always need to do the algebra to find the vertex. In this case, proves that. We can see that the vertex is located at 3, -1. Axis of symmetry is x equals 3. Always that x value of the vertex. And this is the low point on the graph or the minimum. So now that we've done one problem together, let's go ahead and try another. So problem number 2. Again, we have a completed set of x values, so we just need to substitute to find the y values. And when we do that, we get -4, -1, 0, -1, and -4. Plotting the points and connecting them to make a parabola, you should get a parabola that opens down this time. Make sure you have 2 arrows pointing down and that the top is rounded off. Now that we've graphed, we can go ahead and list out our characteristics. Domain is -infinity to infinity. Range is -infinity to 0. Y-intercept, 0, -1. We can see this one on the graph. It's located right here. No algebra necessary. X-intercept. This graph only crosses the x-axis once. In fact, it only touches it. It doesn't really even cross it. Zeros, because there's only one x-intercept, there's only one 0. X equals 1. That x-intercept happens to also be our vertex. 1, 0. And that happens sometimes, and that's okay. Our axis of symmetry equation, x equals 1, and this particular vertex is a maximum or a high point. One more problem together, and then I will give you a problem to do on your own. So on to problem number 3. Hopefully by now you're getting to be a pro at actually creating the graphs. So I'm going to go ahead and skip over that part. If you need help, please, please, please reach out and ask about filling out the table or plotting the points or actually making the parabola. I really want to focus on something that's a little bit different here, and it's the characteristics. We're seeing some different characteristics for the first time here, and I want to make sure I have time to talk about those. Domain, range, and y-intercept, we're hopefully pros at by now. The y-intercept, remember, while we cannot see it, we can still calculate it by plugging in 0 for x. Now for the first time, this is the first time we've seen this graph never crosses the x-axis. And that's okay. Remember back from the characteristic notes that parabolas can cross the x-axis twice, once, or not at all. This is an example of a parabola that doesn't cross at all. So for the x-intercepts, there's the work for finding the y-intercept in case you needed it. I'm sorry, I didn't realize that it was there. Now back to the x-intercepts. Again, this graph doesn't cross the x-axis. So we say none. There are no x-intercepts. And if there are no x-intercepts, there are no zeros. Okay? Vertex we're used to finding. It's that low point here, 4, 1. Axis of symmetry, x equals 4. And this is a minimum. So now you have seen examples of parabolas that cross twice, once, and not at all. We've created 3 parabolas together and done characteristics together. Now I'd like you to hit pause and try problem number 4 on your own. Sorry, I gave a sneak peek there. I didn't realize that. So go ahead and hit pause and try question number 4. Okay, so let's see how you did. You may have gotten a sneak peek at that parabola early, and I'm sorry about that. But if you didn't, let's see how'd you do there. If your parabola is wrong, go ahead and fix it, and then fix whatever characteristics you need to. Now it's important to note that if your parabola is wrong, we will grade your characteristics based off of your parabola. So keep that in mind as you practice this, that if you happen to make a mistake graphing, we'll read your characteristics from your wrong graph. Okay, so now that you fix your parabola if needed and any characteristics, let's see how you did. This particular graph hopefully was not too challenging. I realize that it was the first one that you've done on your own, but you can see everything on here, no substitution necessary. You have 2 x-intercepts. If you are struggling, again, I know I sound like a broken record, please, please, please reach out to myself or Mrs. Newman. Now that we've completed all 4 examples, you are ready to try the practice problems. So go ahead and log into ClassKick and look for the Unit 7 Target 1B worksheet. Thank you and have a good day.